Today we're going to start page 4 of your notes in chapter 3 or chapter 7. It's 7-3. We're going to talk about exponents that are fractions. All the exponents that we've dealt with so far have been integers like x squared, x cubed, x to the 0 power. But exponents can also be fractions, and in this generic example we have x to the m over n. Like this could be a half or 2/3 or 3/4. And here's the rule for fractional exponents. If you have anything, it can be a number or a variable, raised to a fractional exponent, it turns into a radical. And these are the parts of the radical. First of all, the denominator of the fraction becomes the index. The numerator of the fraction is what the whole thing is raised up to. And then the base of this exponential term is the radicand. So there's two different ways of looking at this radical. You can either raise the whole thing to the m power, which is usually the way we do it. It's usually the easier way to evaluate these. But you can also, and these two are the same exact thing, you can have the index here. You always have the denominator becoming the index, but you can raise the base up to the m power instead of the entire radical to the m power. It doesn't matter which one you use. These are equivalent statements. So let's see one of the restrictions that we have with fractional exponents. If n, which is the denominator, is an even number, like if this is x to the 1/2 or x to the 3/4 power or x to the 5/6, if n is an even number, this base can't be negative. But if n is an odd number, if this is x to the 1/3, x to the 4/5, then x can be negative, because if n is an even number, then we would have an imaginary number as a result. And if you could grab your calculator, I'll show you exactly what that means. There's some examples here on the paper. If you take -8, raise it to the 1/3 power, what it becomes is the 3 becomes the index because he's the denominator. The -8 is the radicand because the base becomes the radicand, and it all gets raised to the first power, which we usually don't write. Well, this just means the cubed root of -8, and the cubed root of -8 is -2. It's a real number. If you could grab your calculator, you can prove that to yourself. So grab your calculator. In parentheses, take -8, raise it up to the power of 1/3, and you'll get -2 as a result, which is fine. But if you have a negative base, like -16, but you raise it up to the 1/2 power, well, again, with the rules of fractional exponents, the denominator becomes the index. The numerator becomes the power that the whole thing is taken to, which is the first power, and the -16 becomes the radicand. So what this is asking us to do is find the square root of -16, which is just an imaginary number. If you try that on your calculator, please do this. You take -16, raise it up to the 1/2 power. It's actually asking the calculator to find the square root of -16, and your calculator will give you an error message, just like if you took the square root of -16, you'll get the same result. So that's just a restriction that you have with fractional exponents, but there really aren't any other restrictions. There's a 3-step method to evaluate an expression with a fractional exponent. First of all, fractional exponents become radicals. This is just something that you need to remember. So that's the first step. Rewrite it in radical form, just like up here. Evaluate the root, which means like take the square root or the cubed root, and then evaluate the power, which means take the power of it. So use the numerator to take that whole entire power. So we're going to not use a calculator in this next section. We're going to evaluate or simplify these. All of these have fractional exponents. So number one, if I want to take 25 to the 1/2 power, fractional exponent means a radical. The 1/2, well, the 2 goes in the little v as an index. The 25 goes under as the radicand, and the whole thing is taken to the first power, that numerator. And so it's just asking us to find the square root of 25, which is 5. Number two, we're asked to take 27x to the 1/3 power, so we start writing a radical. Wonderful. The 3 is the index, so the 3 goes in the v. The 27x, the entire thing goes underneath as a radicand, and the whole thing is taken to the first power because of that 1. Well, 27 is a perfect cube, so I'll circle that. The cubed root of 27 is equal to 3, so the 3 will come out, but x is not a perfect cube, so the x has to stay underneath as the radicand. So there's the simplified result for number 2. Number 3, we have 16x to the negative 1/2. Well, now we have a combination of a negative and a fractional exponent. What we're going to do is we're going to take care of the negative exponent first, like we did in the previous pages. A negative exponent turns into a fraction, so it's going to be 1 over. Now we're going to take this 16x and raise it up to the positive 1/2 power, because a negative exponent moves to the denominator and the exponent becomes positive. So we have a fraction here. And now we're going to take care of the 1/2 power, which is a radical. The 2 is in the v. The 16x is underneath, and it gets raised to the first power because of the numerator. So we can simplify this radical because 16 is a perfect square. Square root of 16 is 4. So the final simplified answer is 1 over 4 times the square root of x. And I'm not going to make you rationalize the denominator. But if you had to, you'd multiply by the square root of x over the square root of x. Number 4, here's a numeric example. Like I said, we always take care of the negative first, which is 1 over. And then we're going to take the cubed root, because of the 3, of 125. So this is 1 over 25 to the positive 1/3, which becomes a radical. Well, the cubed root of 125, if you forgot, it's 5, but you can do that. I'll remind you, you press Math, option 4, the cubed root of 125. Your calculator will tell you it's a 5. So this is 1/5. And if you had to check your answer, you can always do 125 raised up to the power of negative 1/3. And point 2, math frac, will give you 1 over 5, which is what we got here. Number 5, now we have a negative base instead of a negative exponent. So since the exponent is positive, it's not a fraction. All it is a radical. The 3 goes in the v, the negative 125 goes underneath, and the whole thing gets raised up to the first power, and the cubed root of negative 125 is negative 5. Because this 3 is an odd number, you can take an odd root of a negative number. Now we have 81 to the negative 1/4. So a negative exponent means 1 over, and now we're taking 1 over 81 to the positive 1/4. Well, that is 1 over the 4th root of 81. And the 4th root of 81 is 3, because 3 times 3 times 3 times 3 is 81. So this becomes 1/3. So if you look at this original problem, 81 to the negative 1/4 power, I wouldn't think automatically that the answer would be 1/3, but it is through all of these rules of exponents. Next one, number 7, 27 to the 2/3. Well, now for the first time we have a numerator that's not a 1. which is not really going to bother us too much. We're going to take this 3 and put it in the V as the index. 27x goes underneath. And then we're going to take that whole thing and we're going to square it. So what this becomes is, we did this before, this 27x to the 1/3 was example 2. So we're going to take this 27 out, take the cubed root of it, which is 3. We're left with the 3 times the cubed root of x, but that whole thing gets squared. So when we square, or we have an exponent, this is like the product, the power of a product. We're going to square the 3, and we can square this cubed root. So this becomes 3 squared is 9, and then the only thing, we really can't do too much to the cubed root of x. Squared, you can either put the 2 here or you can put the 2. It's probably a best idea to put the 2 right next to the x. That's how you'd see it most often. And then the last thing we're going to do is 16x to the 3/4. So write it as a radical. The 4 goes in the V and the 16x goes underneath, and we're going to raise the whole thing to the 3rd power. (16) is a perfect fourth. 2 times 2 times 2 times 2 is 16. So the 4th root of 16 is equal to 2. You can ask your calculator. If you forgot the buttons on the calculator to press, you press math. Whoops. You start out pressing 4 because we're doing the 4th root. Math, option 5, the 4th root of 16 is equal to 2. So we have 2 times the 4th root of x, but that whole thing is raised up to the 3rd power. And notice the parentheses, because this 2 has to get cubed, and so does the 4th root of x. 2 cubed is 8. And then the 4th root of x raised up to the 3rd power, usually you'll write the exponent here beside the x, although you could write it beside the radical way up here. So there's your final answer here. And anytime you want to switch off the video and try any of these on your own, and then turn it on again and see if you were right, it's probably a good idea to practice these on your own. All right, just a few more here. -8 to the 2/3. The 3 goes in the V because it's the denominator. -8 goes here, and the whole thing gets squared. Well, the cubed root of -8 is -2. And when you square -2, you get +4. So +4 is the final answer for number 9. Number 10, oh, we have a negative exponent. Negative exponent means 1 over. 1 over 27x to the +2/3. Well, I'm going to write it as a radical right away, which is the cubed root of 27x. But the whole thing gets squared because of that numerator. We've done this a couple times. The cubed root of 27 moves out and becomes a 3. So this is 1 over 3 times the cubed root of x squared. Whoops, I have to square this whole thing, sorry. Which means I have to square the 3 and square the cubed root of x. So the final answer is 1 over 3 squared is 9, and then we have the cubed root of x squared. So there's that final answer. Number 11, 8 over 27. That's a tall one. 8 over 27. We're going to take the cubed root of that, and then we're going to square the whole thing because the numerator says square it. Well, if you have a fraction, you can take the cubed root of each part. The cubed root of 8 is 2, and the cubed root of 27 is 3. So what we have is 2/3 raised up to the 2nd power. And when you square a fraction, you square the numerator and denominator both, so your answer would be 4 over 9. And the only difference between number 11 and 12 is we have a negative exponent. And if you remember from yesterday or the day before, I told you if you have a negative exponent on a fraction, you're going to flip the fraction upside down this becomes 27/8. And now instead of a negative 2/3, it becomes to the positive 2/3 power. Negative exponent on a fraction flips the fraction. So we're going to take the cubed root of 27/8, and then the whole thing gets squared because of the numerator. So we have 3/2 squared, which is 9/4. Now we have one with variables, x squared y cubed. Well, let's write this in radical form. We have the cubed root of x squared y cubed, and this whole thing is going to get squared in the end. When the exponent is smaller than the index, you're not going to take them out of the radicand. So this x squared has got to stay there because 2 is too small to come out of a cubed root. But when you have this being a multiple, this exponent being a multiple of this index, if you remember, you're going to divide. The cubed root of y cubed is just y, because 3/3 is 1, so this becomes y to the first outside the radical. And inside the radical, you're going to keep the cubed root of x squared, and then the whole thing gets squared. So this becomes y squared, because you have to square each part, and then you get the cubed root of x squared squared. Well, x squared squared is x to the 4th. And now again, we have an exponent that's bigger than the index of 3. So we can split this apart. Y squared stays y squared. The cubed root of x to the 4th is x to the 3rd times x to the 1st. There's a perfect cube that we're going to pull out. The cubed root of x cubed is just x. This is probably the most complicated example, this and number 14, that we'll get. So y squared was always out there. The cubed root of x cubed is just x. And what we're left with is a cubed root of x to the 1st. That was a lot. Now if we have this whole thing to the 3rd power, we're going to apply this power rule, which means we're going to take each part of this to the 3rd power. So this becomes 4 to the 3rd times x to the 1/2 times 3. Well, 1/2 times 3 is 3/2. And then y cubed. Well, 4 cubed, 4 times 4 is 16, times 4 is 64. X to the 3/2 is going to be a radical, so I'm going to write this y cubed next because it's not a radical. And now we're going to take the square root of x cubed. Well, this can be simplified because 3 is bigger than 2. So we have 64y cubed times the square root of x squared times x to simplify it. And then the square root of x squared is just going to move out and become x. So the final answer is 64y cubed times x times the square root of x. You don't have to write that 2 in the index if you don't want to, but you can. So those 13 and 14 are really complicated. All right, now what we're going to do is we're going to take this radical and rewrite it with a fractional exponent. Rational means fraction. So if we have the 4th root of x to the 6, remember the radicand is the base, the 4 is the denominator of the fraction, and the 6 is the numerator. So that's x to the 6/4. And if you wanted to reduce that down, you could call this x to the 3/2. But that's rewritten with a rational exponent. There's an invisible 2 inside a square root index, so you can always write a 2 there. And if we wanted to simplify this, I think the first thing I would do would be to take the square root of 4 and take the square root of b to the 6. Because the square root of b to the 6 is b to the 6/2, which is b cubed. So the 4 moves out and becomes a 2. The b to the 6 moves out and becomes b cubed. And what we're left with is the square root of a. And now there's a little 2 here, and the square root of a is the same thing as a, to the 1 over 2 power. And then the last example, I'm going to take the cubed root of 27, which is going to be a 3. I'm going to take the cubed root of x to the 6, because all you have to do is divide 6 by 3 and get 2. So this is going to be x to the 2nd. And I'm going to take the cubed root of y to the 12th, because 12 divided by 3 is 4, so that's going to become y to the 4th. And the only thing that's going to be left under the radical is the z. So we have 3 x squared y to the 4th times the cubed root of z. And the cubed root of z can be rewritten with a rational exponent as z to the 1 over 3 power. All right, so now the last examples that we'll do today, these last 4 f of x examples, we're just going to substitute a 9 in for x. And this f of 9 becomes 9 to the 3/2 plus 9 to the 1/2. Well, 9 to the 3/2 is the square root of 9 cubed, and 9 to the 1/2 is the square root of 9 to the 1st. Square root of 9 is 3, and 3 cubed is 27. The square root of 9 is 3, 3 to the 1st is 3, and 27 plus 3 is 30. Number 2, 4 times 8 to the 2/3 minus 8 to the 4/3. I'm substituting an 8 in for both of those x's. So 4 times the cubed root of 8 squared minus the cubed root of 8 raised to the 4th power, which is 4 times, the cubed root of 8 is 2, and I'm going to square that. The cubed root of 8 again is 2, and I'm going to raise that to the 4th power. Remember the order of operations. Please excuse my dear Aunt Sally PEMDAS says we do 2 squared, which is 4, and 4 times 4 is 16, minus 2 to the 4th is 16, so this final answer is 16 minus 16, which is 0. Number 3, we have a negative exponent, so it's going to be 1 over, well, you know what, let's multiply 3 by 9 first, because x equals 9, so 3 times 9 is 27. So we have 27 to the negative 1/3. I think I'll write this over here. 27 to the negative 1/3, and then 2 times plus 2 times 9 to the 0 power. Well, 27 to the 1/3 is 1 over 27 to the 1/3, which is the cubed root of 27. And 2 times, well, 9 to the 0 is 1, and 2 times 1 is 2. So we have 1 over, cubed root of 27 is 3, so we have 1/3 plus 2, which is 2 1/3, or if you want to call 2, rewrite that as 6 over 3. 1/3 plus 6/3 is 7/3. So we have 7/3 here. And then the last example of the day, I'm going to substitute a 2 in for both of those x's. So we have 2, this 2 times 2 to the 0 plus 2 to the negative 2 over 2 to the negative 1. 2 times 1 is 2, because 2 to the 0 is 1. 2 to the negative 2 is 1 over 2 squared. 2 to the negative 1 is 1 over 2. So this is 2 plus a 4th, this looks familiar, over a half. I think we did this already once. And then the LCD is 4, because this is a complex fraction, and you want to reduce that, so you're going to multiply through by 4. 2 times 4 is 8. 1/4 times 4 is 1. 1/2 times 4 is 4/2, which is 2. And it looks like 9/2 is the answer. Gosh, I think I've done this before. So that's it for today.